side analysis that we submit. So if we're buying coal, for example, we're going to have to suggest how that is being managed, how the emissions are being managed. If you get down to specific goals that the city might want to take on, this is a pretty good building. It was energy focused when it was built. Do the lights go down on here if you leave a room or something like that? I don't know if they do, but that's one of the things that you can institute is when you leave a room, the lights go down. You know, after a certain amount of time, they shut off automatically. So a public building, cities have controls over public buildings. So is there some way that the city can save energy by doing something with their public buildings? That could be a goal that is established. As I indicated, residential energy use, building rating and disclosure policies. When someone comes in to build a new home, do our building codes represent the latest energy saving codes that are available? I think they do, but I have to research that and find out. Home audits or home energy assessments, we talked a little bit about that. Obviously, that's going to be one of the programs that I will recommend because it's something that can get up and running and minimal cost. And like I said, there's an array of how you go about funding something like that. Older homes have very inefficient appliances. A lot of cities have trade-out programs where we'll trade out refrigerators. Bring us your old refrigerator, we'll subsidize a new refrigerator to save energy. And the analysis obviously is that we're going to save on energy that can compensate for the subsidized commitment that we're making to the resident. You can adopt energy saving targets. A broad one would be we want to in 5 years see our energy 5% less on a per usage basis, or 3% less. So we can come up with energy saving targets as an objective. You know, improve efficiency in local government operations. A good example might be the water utility and how they bring on their equipment. A lot of times, if you have pumps that all get turned on at one time, you spike on it and you hit a big demand, and that can drive your cost if you're having a demand cost issue. Energy information is another one that will be recommended because it's something that we can compile and put out here that everyone can get on how to save energy. As I said, the city utilities, you can expand energy efficiency in that. I think we've already implemented some LED lighting programs. If Dave indicated to me that the street lights have been all converted to LEDs, or most of them have been, a lot of them have. So we've already implemented that, so that will be something that we will show them that we're doing to meet demand side management issues. Smart metering programs, you know, since I've been involved with the city, we've looked at that many, many times, and it's a pretty expensive undertaking and you've got to educate the customer on what you're trying to get accomplished. But smart metering will allow you to do things like manage air conditioning load and cycle those off and on over time. And so I'd have to meet with your distribution guys and find out what they think about smart metering programs, and we'll research vendors and come up with some cost estimates, maybe by circuits, and then we'll provide that to the council and say, here's how much it would cost to go to a smart meter program. We'll present it to you guys first, obviously, and then to the council, but that'll give them a framework to make some decisions from. Do we want to dedicate $400,000, $500,000, $600,000 to implement a smart metering program over the next 5 years? And because you're converting out all your meters for these smart meters. Cities have a need to do water and electric, and that's always pulled the issue down a little bit because water smart metering is not as sophisticated up to speed as electric is. So plus water meters are out on the street, electric is out in the back. So you have a bit of a problem logistically of getting those things implemented, and they create some problems. So those are the broad objectives, specific goals that a city might try to undertake. Maybe I can ask Tony to kind of explain what some of these cities that he's done in the past have done for their programs, and what kind of goals they were trying to accomplish, and that'll kind of give us a little bit more to discuss. Can you do that, Tony?
Yes.
Okay.
I don't know how familiar you are with this integrated resource planning, but the whole notion is that the resources, traditionally the resources in power plants, the supply, where are we going to get our resources to supply our customers? But the integrated resource planning, you look at the consumer side of the equation, what they're going to be using, and then you bring both that integrated together. So a resource can be a generating station, or a resource could be some sort of a way to conserve energy. So for an example, it's a resource, it's integrated resource planning, so you're looking ahead. So let's say your plan is you're expecting a new subdivision with 100 new homes in it. The traditional plan, the traditional way of handling that was just on the supply side of the equation. You'd say, okay, we've got a new subdivision with 100 people coming in, so we got to go out and find some power to serve these people. Go out and buy some power on the supply side. The engineers would figure out the mix of fuel, get a nice portfolio of supply, and that would be it. You take care of your plan that way. Well, integrated resource plan, you look on the demand side. So you look at these 100 houses that are coming on board, and you say, well, we may not need that much supply if we get these people to put in efficient air conditioners, or we have them put in those windows that reflect sunlight. So we've got, our plan says we're going to get 100 houses, but maybe we don't have to get this size of a power plant to handle it. We can get a smaller power plant and have these 100 houses do something on their side of the equation. And so that's where you have a supply side, demand side, and both of them are considered resources. One's a supply resource and one's a demand resource. And then you integrate them, that's your plan. And when you look at those two sides, a power plant's going to cost you so much per kilowatt hour, and then to save energy, it's going to cost you so much to put in these sun-reflecting windows. So you figure out a way to measure cost on both sides, and you figure out which is the most cost-effective. Should we spend $10 for this power plant, or should we spend $8 to put up these windows? And if it was that simple, you'd say, well, guys, it's cheaper. Well, we're going to look at it all together. We're going to look at both sides, and the cheapest way is to put in these $8 windows. And that's the way you go forward. So you've got to have, you look at both sides of the equation, the supply side, demand side, and you look at ways to save energy and become more efficient. And because that's more of a new type thing, well, not all that new, but there's some new technologies on the energy saving, of course. So you look at those things, and then you've got to figure out some way to measure the cost. And you put them on a level playing field. If it costs $10 to supply the energy versus $8 for the energy savings, and you go to the energy savers. But that measurement itself can be a bit of a problem, because some people, depending on how sophisticated you want to get, they'll look at the energy saving, they'll say, let's consider the societal costs, air pollution and such. It's hard to measure that. But you might have it where if it's $10 on both sides of the equation, you might lean toward the energy saving, because you know you got pollution on the other side. You don't know how to quantify it, but it might tip the scale. So that's kind of the terminology we're kind of using on this integrated resource When I worked on these earlier projects, it was for small towns in west